thank you very much for joining. This is my name is Benoit Gervais, and this is Ali with us. We're both are or have been application engineers and familiar with SpaceClaim Sheetmetal. This is specifically going over SpaceClaim Sheetmetal capabilities. We get a lot of common support questions from different customers, and we thought we'd put together a webinar to kind of go over an overview of the most common issues that we see typically with questions that we get from sheet metal customers. So moving on, Ansys basically acquired SpaceClaim a few years ago, and SpaceClaim basically partnered with Trump, which is a sheet metal manufacturing machine company. And they wanted us to work on a tool set that worked in conjunction with common features that their machines had. So SpaceClaim worked very closely with Trump to be able to develop their tool set. And the whole point was really to be able to prepare data or files for creating sheet metal parts using the Trump machining equipment. Moving on, common problems that we typically see with our customers. One is, first of all, customers will get data from our customers will get data from their customers. So their customers will often send broken 3D CAD models. Sometimes they come in broken, sometimes they're not. And oftentimes these models are created in non-sheet metal feature or poor sheet metal feature tool sets of different types. And so they will get a model typically that has, maybe broken or not broken, but a lot of times the sheet metal features are not really easily manufactured. So oftentimes there's modification of some of the small features, such as the bends, the reliefs, the splits, etc. on the parts. Next, sometimes customers even won't get a 3D model. They will get sometimes PDF drawings or DXF files. And some of the lower volume customers that we talk to, they'll even get a customer walk in and they will just sketch out the design that they want on a piece of paper or a napkin, basically explaining the features they're looking for. So it's very challenging because the customers typically that we see that are trying to create these parts have to interpret and create their own data to be able to bring that to their laser cutting machines and bring it out on the floor to be able to produce these parts. Next thing, a lot of customers we have need to create a flat pattern in order to bend up the sheet metal parts. And a lot of our customers now have their own cutting machines, typically laser cutting or water jet cutting machines, in order to be able to create these parts. And they will often have to take that flattened out pattern and bring that as a 2D file into their laser cutting programming tools. And sometimes laser cutting programming tools have difficulty understanding the 2D files. Sometimes the 2D files need to be modified or repaired. So again, that's another common issue that we see is just bringing that 3D model and transitioning it into their laser programming. Lastly, for some of the more complex parts, our customers will have to bring those the drawings to their technicians on the floor, and they need to be able to communicate the manufacturing or the bend sequence and post-processing of these parts accurately. So sometimes data such as drawings or manufacturing process documents need to be created. Sometimes it could just be simple as notes on a drawing. Sometimes it'd be complex as like actual documentation. But again, that has to be communicated to the technicians, because sometimes what we hear is that they have difficulty telling them what bend sequences that need to be done, what tooling to use, what the distance from the brake machine needs to be, what processing notes need to be put on, such as maybe using turrets, maybe adding in finishing, such as paint marks or different stuff. So again, manufacturing planning, especially on the larger volume complex parts, is quite important. Some of the SpaceClaim capabilities that can help. One, we can, from scratch, if you want, say you were to get a napkin sketch from someone, you could create a 3D solid model in SpaceClaim using the push-pull and converting it into a sheet metal body quite easily. SpaceClaim is a very, very powerful and very easy to use sheet metal design capability. So you can actually create those 3 models from scratch. Also, you can easily go in and modify sheet metal features such as bends, reliefs, and splits. So you can like play around and adjust some of these features in order to optimize your nesting and your manufacturing manufacturing ease. So you can go in and adjust some of these features. Some of them might be difficult to manufacture. So going in and modifying or adjusting some of the reliefs and the bends can really help with the manufacturing down the line. Thirdly, also beyond designing from scratch, more importantly, what many of our customers get is actual CAD files. So taking in dumb CAD files, and when I say dumb CAD files, I mean IGES files, step models, different types of models that basically have no intelligence. You can bring those into SpaceClaim, and using the sheet metal conversion tool, you can actually take that sheet metal body, convert it back, repair it, and then get the unfold pattern in order to be able to bring that to your floor. Additionally, not many of our customers use this, but some of the more advanced manufacturing facilities we see use this is they will want to add in some additional capabilities into the part or additional features in order to make the design more robust. So for example, we have integrated hinges as opposed to like adding in hinges as separate pieces. So you can add in hinges automatically at the joints. If you want to add in stiffness or strength to your parts, you can add in double walls. And also what we see a lot is for weld planning and weld fixturing, you can even add in your own tabs on the edges in order to be able to fixture the part more easily to be able to make the joints. Also with SpaceClaim, we have the ability to bring in DXF files or even picture files such as JPEGs or PNGs, and actually go in and convert or trace those files and turn those into 3D sheet metal models. That's something that a lot of the lower volume customers we see deal with. They will get customers that don't have any CAD capability, or they don't really are not very computer literate, and they will want to be able to go in and just take like their concept and allow the manufacturer to design it for them. Lastly, for bringing the flat patterns once to the laser cutting programming, we also have the ability to fix 2D files such as DXFs or DWGs, which are commonly the file types that a lot of the laser cutting machines take. So we can actually go in and modify, for example, taking some complex splines and turning them into rounds or lines. And so that way the laser cutter can more easily program the flat pattern. So that's pretty much it for the SpaceClaim capabilities. I'm going to hand it over now to Ali, and Ali's going to actually show you in SpaceClaim and demonstrate some of the capabilities I just discussed. So Ali, I'll let you take over.
Thank you very much, Ben, for that great presentation. Good afternoon, all. So this is the basic interface of SpaceClaim. Today we'll just we'll go through the basic sheet metal tab, and we'll see how easy it is to just create a sheet metal part. Then moving on, we'll go and create a 3D geometry while going into the design, and we'll see how easy it is to just convert that 3D design into sheet metal. And then we will see if we are just importing models from outside. So let's just begin. So as you can see, if I just go on and create a new document, over here we have our 3D interface in which I can just go into the sketch and start sketching the sheet metal part. From here, if I just create anything, that will be created as a flat. If say I want to add something in it, I can just create another sketch, just adjacent to it, and it will be attached toward that very flat. Now if I just move out of this tool and use the pull tool. Over here in SpaceClaim, all the tools are aggregated into the one or two tools. For example, in most of the design things, we will use just pull and move to have variety of tasks. So if, for example, I'll just go into pull and double click on the edge, I'm able to, if just I move it upwards, I will be able to create a flange in upward direction. Although if I just move it in downward direction, the flange direction will be reversed. And these flanges will automatically have those junctions and edge reliefs. These are not junctions. If I just go over there and tap on it, they are dynamic. That is, if I just hover over it, I can just change the type of junction that we have right now at this very junction. So say if I just want to have a partial overlap, or say I want no overlap at this very condition, then I can choose so. Let's keep it as a band. Now, apart from the bend, we also have different kind of edge relief. So if I just click on the edge relief, I can change the different kind of edge relief that I want to give. Say I want this edge to be a triangular in shape, or say I want it to be of a different shape. I can choose from this dialog box. Once I'm done with it, say I want to add more flanges, I can just click on to the edge and just go to the pull tool, and I can just again create a flange over here. Say I do not want to create a flange onto the all of the edge, complete of the edge. Then I have a little sphere over here. I can just move this sphere from one direction to the other to just limit the flange, and then I can just pull, and the flange will be in a limited area. Now say I've created some kind of a sketch and created a 3D CAD model. I want to see if, say, I am able to manufacture this very component or not. So I'll just click over here and just go to the unfold. As I click on the unfold, it will show me that this part is not manufacturable by the sheet metal technique because there is interference between these parts. So in SpaceClaim, I can just take this unfolded tab and just place it just right to my CAD model. Now I can see that there are some junctions that need to be changed. So I can just alter it over in the left side, and I can see the effect on the right. Say I have an intersection over here. So let's change some things over here. So let's change the junction to band over here and change it to no overlap. So at this very condition, we were able to remove the interference. Let's move on to this place and try to do the same over here. So again, over here, we were able to change the interference. But again, there is one interference between here. So I can again change it from here and change a band over here. So this might not be the optimal one because we have a area over here. But over this, using these features, we can know if our CAD geometry is a manufacturable or not. Now moving on, say I have some kind of conceptual design in my mind and I want to design it as a 3D CAD model and then convert into say sheet metal part. So for that I can just again go to a sketch and start sketching something that I have in my mind. Say I have created something inside my mind and I just want to create it through 3D design. So where I've created a rectangular box. So if I just click over the edge, as you can see, there are multiple features that we can do. So as I told you that all the tools are consolidated in one tool that is called pull. If say I double click over the edge, I get multiple features which I can choose to operate on this very edge. Say I want to copy the edges and I do not want to do the work again and again. To create a sketch, I can copy these sketches onto the different location of this very body. Again, I can use just the pull tool to just change the dimensions. In the pull tool, we also have something on pivot. I can pivot the edges in upward or downward direction, or I can move it horizontal and vertical. So if say I want to pivot two edges, I can do that. So select these edges and I can pivot these along. Now say I want to place a hole at the top. So I can just go over there and sketch it. And I can just place a hole over there. Now the sketch has been created. I can pull it to create a pin or I can just create a hole. In another CAD software, if I just go, I want to just move this very hole or this very cylindrical hole from one place to another, it will be quite difficult, right? Over here, we do not know to create a plane or again sketch or worry about the structure tree, because over here, everything is parametric. We do not have a predefined history over here, although if we want, we can create through blocks. So if say I want to just move this thing, I can just go to move and move this cylindrical from one place to another. Say I want to rotate it, the same thing can be done by rotating through this axis. So say I want to create a copy of it, I can just press Control from my keyboard and copy this cylinder from one place to another, and again copy it one place to another. Say I have got what I wanted, so let's start creating a sheet metal out of it. So I can just create a shell out of it so that it will define the sheet metal boundaries. Let's just, okay, let's go to shell and remove these things. All right, so we have a shelled solid now. So now I can just go to sheet metal and go to convert and click on any of the faces. Now it will show me that there are 16 sharp edges and I need to define on which edge I want which kind of a junction. Say I want a junction that is bent. So I can just go to convert. Second. Shell it out again. Go to sheet metal and convert this. Now I can select the edges and give the junction type. Currently the junction type is selected to be bend. So if I just go one by one and select these sharp edges, I can select the junction type to be bend. Let's select some junction to be bend, and then let's see if we can just unfold it. So say I have selected the junction type bend on some of the regions, and for the others I just want to be have no overlap. I can just select others and give overlap to others. Now let's unfold this very component. And as you can see, there are some errors. The software is not able to unfold it because as you can see over here, there are bends and this is limiting the motion of this very sheet. So let's again move it right to our 3D CAD model. So over here, we can see what we can do. So we can either change the type of junction or we can just create a kind of a split over here to just split this thing. Let me just place a split right here. All right. So I split it, but again, there is an intersection over here. There is having an interference. So I can just go back and just change the type of junction that we have. Let's say I want to just change the junction to no overlap, and from here also no overlap. So this side was able to open up. So let's do the similar thing on the other side. And here we have the opened unfolded solid part that we have created from conceptual design. So let's move on to next thing. As we can know that from different vendors, we can get files of different type. So over here, if I just go to all supported files, I can select different types of file that can be imported. Say I have a part from SolidWorks, there's no problem in it. We can just import it in SpaceClaim directly. Let's wait for a couple of seconds till it completes the import. So yeah, it has imported a 3D CAD file, but it hasn't detected anything that it is a sheet metal because it is a dump file over here. So if say I want to change something, if I say I want to change a dimension over here, so it will not recognize that it is a sheet metal part. It will create a 3D solid out of it. And say if I want to unfold it, then then do I need to redesign it using sheet metal? No, we do not need to do so. We just need to go to the convert and select any of the face, and SpaceClaim will go ahead and try to convert it into sheet metal. Once it's converted, we can just go to identify and identify different type of features, sheet metal features that we can have in this very 3D CAD. So it has identified 3 beats. Let's check mark for those. Now let's check if there are any forms in this. So it has site for 33 different kind of forms. But as I can see, there are different cutouts that it has detected as forms, but I do not want them to be detected as forms. So I can just ignore these cutouts and click the check mark. Now, if I just make any changes over here, so it will remember that it is a sheet metal part. So it is not changing the thickness over here. Now it's no more a dump CAD file. It's now a sheet metal part. If say I want to just move it in certain directions, so it will take care of the band and change the dimensions accordingly. So now if say I just go ahead and unfold it, I can do it easily, right? So here we have the unfolded part. The other thing that we have in here are called layers. Say I want to signify and show the band line before importing or converting into DXF file. So I can just uh, uh, load or show these lines. So I can show the band lines over here. I have the band dimensions, and I do have the forms. If say I want to give the kind of forms that we have at different places, I can show it by clicking on the forms. Let's move on to the next model. So let's say we have gotten another model that is in a format of SGP. So it is also a dump CAD. But if say I want to just go ahead and convert this dump CAD, it is doing nothing, right? So why is it so? If say I just select this surface and go to convert and select the other reference face, it shows me that sheet metal conversion error, no offset faces found. What it means to say is that this sheet metal part does not have a constant thickness. Let's check for it once. So if I just go over here and select this very edge, I can see it's a dimension of 1.52 mm. All right, let's check at another place. It has a dimension of 1.6 mm. So the dimension or the thickness is not constant throughout the model, due to which it is not able to convert. So it will be quite hard for just making it again. It will be time consuming, right? So not over here. So I can just control select all these surfaces, press copy from my keyboard, Control plus C, or I can just go into Sketch and do a copy from here, and I can just do a paste. As you can see in the structure tree, I'll have a solid and a surface. If I just hide the solid, I can see I've created a surface just above this very solid. Now if I can just select this all and go to our pull tool, then I can just create a thickness of say 1 mm. Now if I just go to sheet metal and convert this thing, it is easily converted, and let's select the bands to be band junction type to be a band. So now we have converted, and this is a sheet metal part. Now if I just unfold it, we'll have the unfold. Now just one more thing I just want to show over here is that if I just go to SM repair this file and just go to the options, I can see the K factor over here. So right now the K factor type is variable, and the K factor is for R is equal to 2, the K factor is this thing. Say I want to change a K factor over here. As soon as I change the K factor here, the dimensions here will automatically change, that it is dynamic in nature. It will make sure that the dimensions that we have in the unfolded part is completely calculated by the use of K factor. So if say I want to define more settings of sheet metal, I can just go to SpaceClaim options and just go to sheet metal and give the K factor to be variable or constant, or just a constant value to how much. So I can just give here. Now let's say we have another model over here. So this is a sheet model from before. So say over here I want to add a certain kind of a double wall. So I can just go to double wall in here and just click any of the surface and click any of the edge. I'll be able to create a double wall. So it will strengthen my part. And if say I want to have a double wall in complete of the part, so I can just select all of this and then select the edge. One thing you might have noted that in the creating the double wall, the other wall that we have is just having all the features that we had in the initial layer. So if I just unfold it, all the features of the interior layer have been copied to outer layer. And also it has been taken care of by the software that the band radius are different for the wall and for the initial part. Let's go back and delete this say wall. Another thing that we might encounter in SpaceClaim is, say I just unfold this very component, you can see that there is something over here. As you can see, these edges aren't parallel, right? So we just go to our model and I just click on squared up edges. It will try to find all the edges which are not squared up. And we just click off a button on the surface, these edges will be squared up. If I just unfold it, I can see that there are no unparalleled edges over here. Let's say I want to include a hinge over here on this very edge. So do I need to design it? No, we do not need to design. We just need to click this button over here that is called hinge and just click the edge on which I want to place the hinge. So it will show me a visual effect how that hinge will look, and I can change various parameters of this hinge from this option. We have the pin diameter, we have pitch, we have knuckle length to vary, and we can vary the end plane. Let's say I'm good with this thing right now, so I can just click the check mark and the hinge will be created. If I now just go to unfold, the pattern of the hinge will be over there in the unfolded part. That we have is a DXF file. Say I want to convert a DXF file to a 3D CAD models. It will be quite difficult to just check the drawing and just go into the sketch panel and sketch it. So over here, I can just copy this very drawing from this DXF file and I can just create a new design in here and I can paste it. Again, I can just go back and copy the other layer of the DXF file and paste it in the design. Once I have it, I can just go to 3D mode, or say if I want to just redefine these curves. As you can see, these curves aren't a perfect curve. There are multiple points that we have in this very curve. So say I want to just repair this and have a clean cut for a laser cut. So I can just go to repair and just fit this curve. I can select what kind of fitting that I want. Do I want to use lines and arcs, or say I just want to use lines or splines? As you can see, spline is perfectly fitting over here. I can click the check mark and it will be the those multiple points will be replaced. It's been converted into a surface. Now I can just select this surface and just move this so that I can just orient this perpendicular to this very plate. Now I can just move this blob around this point and just orient this closer to this bottom one surface in here. Again, within the Y direction, I can just use the up to command to just snap it to the topmost base. And if I want to just go to the DXF file, same kind of pattern is on the other end. So I can just again use the same move tool and press Control from the keyboard, go to up to and move this surface to other end. Now once I have it, we have the basic drawing that we can now convert into a 3D model. Now if I just go to sketch, design, go to pull, I can select the complete of this and give the dimensions, say 1.59, or I can just use the snap that we have over here. That is, I can use up to and create a snapping till here. Then I can use the same snapping for the other surface, use the pull and select up to and create snapping till here. So the dimension is 1.59. So I can just select all of this surface and pull it up to 1.59 mm. Once I have it, we have created just a basic 3D CAD model. But as I can see, there are something that is missing over here. So what I need to do, I need to go back to the sketch and redo all of this. No, I do not want to do. There are two ways to do it. One is to just box select all of these surfaces and use fill, which is quite easy. The other way is to manually select the surfaces. So I can select one surface from here, then holding control, I can even select the surfaces which are not visible to me. So I can select these surfaces and again use the fill tool. So we have created the basic design that we intended to create. Now I can just go to sheet metal and convert it. Now if I just convert this one, again it will show me the sharp edges. I can click over here and over here the bands will be created. For the last thing that we have in the DXF is this flange. So I can just go to this very edge, go to pull, and again create a flange of say 14 mm. Right? If I just go back to design, it is about 14, right? So we have created a sheet metal directly from a DXF file with minimum going back and forth to the DXF file, just copying the basic layout. So if I just now go and unfold it, within a couple of minutes, we have the unfold of that very DXF file. Let's see, do we have anything else? Yeah, we have a motherboard. Let's load that up.
I have a question, I guess. So,
Yeah.
when you take a step model and you're converting it to a sheet metal part, I guess it automatically assigns a K value of 0.5, or does the K value come from the material?
So for the K value, we have it within a SpaceClaim that is predefined. So if I just share the other document that we have for K values, just a second. Just share this document. So over here, this is the guide of SpaceClaim. So K value is not constant in SpaceClaim. It depends upon the thickness of the sheet metal part. So depending upon the thickness, the K value is defined within SpaceClaim. Although if say I want to edit this K value, I can create it to be a constant that I've shown while going into the SpaceClaim option. Or the other way is to just again. So the other way is we have a band documents in here. So if I just go to this program files and I want to manually have a variable kind of K value. So in SpaceClaim folder, we have something called sample.csv. So if I just go into this CSV, I can just edit the different parameter for which thickness, say for 1 mm thickness, for different radius, what should be the K value for different bending angles. So these band detection tangent table can be given manually if you want.
Cool, thank you.
Does that answer your question?
If you don't mind me asking, Kyle, what's the reason you were asking? Is there something you guys deal with K factors for getting it on the floor?
So I'm using SolidWorks right now, and the K value does not change. And I get a lot of complaints from the sheet metal guys saying that my flat patterns aren't very good. And I see now it's because my K value is constant and it does not change as per the thickness. And that's really a big reason why I wanted to sit in on today, because I want to do some test pieces now where I'm going to make it in SpaceClaim, and then I'm also going to make it in SolidWorks, and I'm going to try a couple things there, and because yeah, this could be quite helpful. I'm using SpaceClaim more and more and more now.
Well, what we could do, Kyle, like we could show you quickly how to do the K factor right now, but if you want, we could go offline and have a separate support session with you for like a half an hour.
Yeah.
And we could walk you through how to actually do that in SpaceClaim. It's actually quite simple to do in Space. It's would that be of interest to you, or?
Yeah, absolutely. Why not? You know, what I might want to do though, if that's okay, is just play around with it a little bit more first.
Of course, of course.
Because I think I could probably figure out some, you know, and just looking at this now.
Yeah. So over here, as you can see, that K factor type is variable that I showed in the PDF. Say if you want constant K factor, I can give just constant value in here. Or say I want to refer it to the document that I showed before. So I can just go into sample over here, and now it will take those values within that Excel file and assign it to our model in here.
Yeah. No, this is very helpful, because I'm using a constant K value. I think I use 0.5 for everything.
Right.
And that's no good. I'm just realizing that now. So.
Ali, could you maybe create a video for Kyle just to show him how to do this, and then that way he could play around with it?
Yeah, definitely. Yeah. I'll send out a video describing how to change the K value in detail.
Okay, thank you. Appreciate it.
Yeah, this has been very helpful. I'm picking up on a lot of what you're doing there. I'm also really interested in taking a step file or an IGES and converting it to sheet metal and then making the flat pattern. That would be very, very useful for me as well. But I see how you've done that, so now I want to go and play with that a little bit myself and see how that works. Because I didn't realize actually that SpaceClaim did all of this actually. I mean, I saw it there. Yeah, I just didn't realize that it was. Yeah.
We typically don't talk about it a lot with. It's mainly like specifically only sheet metal manufacturers. I guess you guys do like design and all kinds of other things there, so I guess we don't promote it as much, but yeah, we've been getting so many requests. That's why we decided to run this webinar. So
cool. Yeah, and I'll share it with my colleagues there that you guys are doing this, because I'm sure other guys are going to be interested in this as well.
Okay, perfect. Okay, thank you, Kyle. Appreciate that. Yeah, wonderful.
Yeah. So let's get back to the demonstration. So I loaded up this motherboard, or this is an electrical component for which say I want to create a housing. So I can just quickly go ahead and sketch something over here into sheet metal and create a basic sketch. Let's orient it the right way, create a center rectangle and create a sheet in here. Now once I have the sheet, I can just go back to a 3D view and move this flat a bit away just through the move tool over here. So again, I can just click on the edges to select all the edges at once. Go to the pull tool and say I want to have a flange of 75 mm and press enter. Let's set it to transparent so I can see what are the things that we have inside it. So let's select this to transparent. Now I can see over here. So let's move it a bit inside so that I can have some of the features in here. All right. So we want cutout for these features, right? So that we can plug and play different kind of devices which we can connect with this very motherboard. So I can just use the simple combine and cut tool over here. So combine, cut this thing, right from here. Again, cut this thing and cut from this one, and this one. Hide others. So we have our cutouts over here. For these cutouts, we have complete cutout. For the other one, we just have have just a sketch on which we can just again sketch and remove the material from in here. Let's remove the material from here. Again, I'll just go to the pull and just remove the material in here. I just show all. We have created a housing, some kind of a housing over here. Again, I can just add a, say we want to just close this out. Just click on the edge, again go to pull. And again, I can just pull it to close this housing. Right. Say for the fan, I want to just create a cutout in here. Again, I can just simply go into the sketch. And just start drawing the layout of which I want to just remove out of here. Let's say I just create a cutout in here. Just go to pull, create and just pull this out. So now we have a space through which the air will be removed. Now if I want to, instead of having this band in here, I want to change it and have something else. And just go to sheet metal. So I can just do sheet metal, change the junction type to no overlap. And now I can just zoom in a bit, click on the hinge. Click on the hinge, click on the edge. It will again try to generate a preview for me for that very hinge. And I can just, once I have that hinge, I can just click the check mark and create that hinge at that very location. So that's it for this webinar. If you have any questions, please feel free.
Yeah, no questions from me, but thank you very much for this presentation. This has been very helpful.
Yeah, thanks, Ali.
Yeah.
It was really wonderful. It was very thorough. Thank you so much.
Thank you very much, Ben. Yeah.
Go
So
ahead,
Kyle,
Ali.
if you have any trouble while using this various things that I've shown you today in the demonstration, I can just help you out. You just shoot me a mail regarding anything that you want support for. We can set up a personal demo or personal support call for you to solve your issue or just give a little bit demonstration in bit detail.
Well, thank you very much. That would be wonderful.
Yeah, you're welcome.
Perfect. Yeah, Ben. Thank you so much. We'll be sending this webinar out to everyone that registered. It'll be a public link. It'll also be on our website. If you have any additional questions, like Ali said, feel free to fire them off to our team. You can fire them directly to Ash, who's our marketing, managing all the marketing for us. Yeah, feel free to also let us know if there's any other topics you'd like covered. I know SpaceClaim, we get a lot of requests for different types of topics to be discussed, like reverse engineering, 3D printing, design, advanced surfacing, etc. So if there's any other webinar topics you'd like us to cover, we're always looking for input, so feel free to fire those off to Ash or ourselves, and we'll make sure to incorporate that into our curriculum. So thank you so much for attending. Take care and enjoy the nice weather. Okay.
Thank
Bye
you.
now.
Thank you for joining. Have a great day all. Bye-bye.
Bye.